Alright guys, welcome back. Today we're going to be going over the tutorial acids, bases, and buffers. Now, one thing I want to note before we start is that I've gone through this tutorial just to look at it, and it's very in-depth. So I can understand why this particular section might confuse you a bit. I'm going to simplify it down, and I'm going to not follow the tutorial virtually at all. Alright, I might highlight a page if I so feel like it as we get halfway through this video, but I think I'm just going to teach the basics in a more generalized way. Alright, this should be good enough to get you through the mastery test, and it might be good enough to get you through the post test as well. I'm going to note a couple of things that I think you might need to know for the post test. Alright, so let's start by just introducing the pH system. Alright, you have a pH system. And that pH system is going to be how we scale the strength of acids and bases. It pretty much means that some acids are stronger than others. Like, obviously, you can pour lemon juice on yourself, and that's a pretty strong acid. But if you throw, like, hydrochloric acid on yourself, it's going to burn you, so that's even worse. That kind of thing. There are all sorts of things. Bleach is a base, and that's obviously really, really dangerous, but there are also slighter bases, which we'll talk about, all of that. pH, you don't really have to worry about this, but pH stands for potential hydrogen, and what that means is that you're going to be dealing with hydrogen in different ways, and that determines whether or not you're dealing with an acid or a base. Alright, so I said we're going to talk about acids and bases. So I'm going to introduce the very basics of acids and bases to you guys right now. That way we all are on the same page. Here's the pH system. It's going to be a scale, and I don't really care which way you write it, but I'm going to write it left to right. Alright, here's your pH scale. Alright, and from now on, acids are going to be on this side of the paper, and bases are going to be on the other side. Alright, so here at this midline, you know what? Let's pretend it doesn't go out here. So imagine this is it, and this is like the middle of the line. So this middle part is going to be 7. 7 is our middle value. It's essentially our start from 0, our neutral spot. Okay, so this is a key spot. By the way, this is where water sits. So water is considered neutral. All of this is based on water, and we'll talk about why that is in a little bit. Alright, so that's H2O right in the middle there. And obviously you can go up and down in either way. So let's go down here. 6, 5, 4, 3, 2, and 1. So here's 1. So again, ignore all that stuff. Don't worry about that. So it goes from 1 to 6, 2, 3, 4, 5, 6. And then from 7 up to 8, 9, 10, 11, 12, 13. Alright, so I ran out of room but 14. That's supposed to go out to 14. So just, you get the idea. Alright, so you have this pH scale from 1 to 14. And water is right in the middle. Acids are going to be on the left of the scale. They're going to be the lower numbers. Bases are going to be on the right. Now, I know this is counterintuitive because you think the base would be the lower value because it's the bottom of the base. We are actually going to think opposite with pH scale. I kind of know why they do that, but we're not going to go into that detail. To explain why they do that would be a whole lot. So don't worry about it too much. Just remember this right side, the larger numbers are bases. The smaller numbers are going to be acids, okay? And conversely, the lower and lower you get, the more acidic you get, okay? So if you get a really, really low number, you're very, very acidic. Like, I think lemon sits somewhere in this area. This is like lemons. So lemons are somewhere in the middle of the acid scale. They're pretty strong, but it's not like they're going to burn your skin strong like way over here. All right? So that is acids. And then bases, as you get higher, they get more basic. This kind of makes sense in that if water is neutral, water doesn't burn you, doesn't really. It's really nice because it just neutralizes everything. Is right in the middle. All right, so it makes everything weaker. That's why we dilute things with water. Okay, as you get higher and higher, so further away from water, you get more and more something else. You either get more basic or more acidic, depending on which way you get. Alright, so that is the pH system. That's an introduction to acids and bases. I'm going to introduce one more thing. Just remember acids. I'm going to have you memorize this. I won't describe it too much. It is in your tutorial, but I really think that this is part of the thing that makes your tutorial really hard to follow. Acids are based on H pluses. Alright, these are hydrogen pluses. The more of these you have, the more acidic you are. So basically, a 4 has like 10 H pluses, but a 1 would have like 1,000. Okay. That's not actually true, but you get the idea. So the more acidic you get, the more H pluses you get. On the other hand, with the basic side, you're not going to have H pluses. All right, you're going to have OH negatives. These are called hydroxides. So this is a hydrogen, which you guys have probably seen before. This one's a little different. This is going to be called a hydroxyl. Hydroxyl. Okay, so I wrote that kind of sloppy, but don't even worry about it. The idea is that you have your basic side and your acidic side, and you'll just have to kind of memorize this. Do you necessarily have to understand why? Not really. You just have to remember that more acidic is more H pluses, more basic is more hydroxyls. 7, water is right in the middle. It basically has 1 H plus, 1 OH. That's how that works. And that actually makes perfect sense because if you think about it that way, it has 1 of each, right? That's 1 hydrogen, 2 hydrogens, and an oxygen. What is the chemical formula for water? Exactly right. It's H. You can see that? Yeah, you can. 2O. Okay, so water is right in the middle here. All good? So this is how the pH scale works. What I want to note is this. You can neutralize an acid or a base with the opposite. Okay, so you basically have to get them and average them back to 7. Alright, so basically if I go 1 up and I go 8, a basic of 8, if for whatever reason somehow I burn myself with something with a base of 8, I need to use an acid of 6. When I mix an acid of 6 and a base of 8 together, I'll get 7. I'll get a water. Okay? Same thing happens if I have a 1. Let's say I burn myself with a really, really strong acid. Okay? Honestly, I'm Googling right now some examples because I don't really know what would have a pH of 1. I've never been burned by something like that. So let's go ahead and take a look. Okay, liquid drain cleaner apparently has a pH of 1. I didn't know that. Apparently drain cleaner is like really, really strong, so whatever. I'm sure not all drain cleaners, so you can't just go buy Drano and it's really, really strong, but some kind of drain cleaner apparently is really, really strong. So let's say I get that and I don't know, I put it on my skin and it's burning, and my hand's just on fire and I'm screaming, right? The way you neutralize that is you're going to need something like hydrofluoric. I'm sorry. Oh, okay, my bad. So drain cleaner would be a base. It would be a 14. Alright, so 14 is like drain cleaner. Drano or something like that. It's not really Drano, but whatever. I'm going to call it Drano. So I need to balance that out with a really, really strong acid. So I'm going to use something like hydrofluoric acid. Okay, so here's a 1. That's going to be hydrofluoric acid. So fluoric acid. And if you mix these two together, you can actually get water out of it. So if I mix like 1 cup of this and 1 cup of this together, I will end up with water. It'll be safe to drink. Like, don't drink it. Don't do all that because you'll probably mess it up. To actually find the accurate base and the accurate acid is really, really hard to do. So I wouldn't bother. But let's see. Tomato juice is actually an acidity of about 4-ish. So if you were to take tomato juice and something with a base of 10, something close to like milk of magnesia, you guys don't have to worry about what that is, but milk of magnesia is this weird base. It's not really all that dangerous. People use it to quell stomach issues. I think it's used in Pepto-Bismol and that kind of thing. So if you were to mix that with tomato juice and whatnot, you would end up with a neutrality equal to water. Like, water is not the only 7. If you mix those two things, it's not like I'm suddenly going to have water, but what I'm going to have is something with a pH of 7, so it's as safe as water. It might taste terrible, so I recommend against it. Don't try that. Alright, so acids and bases cancel each other out. If I have a really, really strong acid, I can use a strong base. They'll neutralize and we'll be all good. Okay? So, let's see. Oh, on your mastery test, you're going to run into a question that asks you about vinegar. Just remember, vinegar and limes, I guess, limes and lemons, limes/lemons, they're going to have a very low pH, which means they are acids. I don't know why. They're going to ask you really specific questions about like particular things. So I gave you hydrofluoric acid and Drano, vinegar, limes and lemons, and water. So just understand their pHs. Just remember, vinegar is an acid. Like, it's on really, really low on the scale. I think it's like a 3 or 2 or something like that. So it's just low on the scale. All right. So keep that in mind that it is low on the scale. It is an acid. not a base. All right, and then further um, for your mastery test, they're actually going to ask you about buffers in detail. So buffers are essentially systems in place that keep your pH at a neutral level. So your body is going to be at a certain pH, and your body wants to keep homeostasis. So if you remember from lecture 1, we talked about one of the themes is balance or regulation, homeostasis, and our bodies want to stay at virtually neutral. We're actually a little bit basic. We're a little bit, so everybody's a little basic. But anyway, we're a little basic. I'm also going to use the word alkaline. I don't really know if they went over that in your tutorial, but I want to highlight that word now because I normally use the words alkalinic instead of basic because it makes me think of, yeah, whatever. So alkalinic is a lot easier for me to follow personally, and plus you guys know what alkaline batteries are, right? That's like, AA batteries and whatnot, Duracell, all that jazz. Those batteries, I don't know if you guys have licked them or not, but when you lick them, they give you that little shock of a juice, that like bitter taste. So bases are bitter. So bases are bitter tasting as a general whole. And so you can think of things that taste bitter, and they're probably basic in nature. Acids, on the other hand, like lemons and vinegar, are sour. Okay? So things that are sour are acids, things that are bitter are bases, or alkaline. Alright, so alkaline batteries, when you lick them, you get that little shock, and it's a little bit bitter. Okay. So, again, we're talking about buffers. So like I said, buffers are systems in place that keep your pH at a certain level. In our case, we want it at 7, a little bit higher than 7, so it's just slightly more alkalinic, slightly more basic. So our bodies, let me do this actually, the pH of the human body is 7.4. Okay, cool. So yeah, our pH is somewhere about here. So we're a human body. It's about 7.4, and we want to keep it there. So when you eat things, like let's say you eat a lot of lemons, I don't know why you would, but pretend you do eat a lot of lemons. Technically, this would start moving our pH that way. There's a buffer system called, ooh, I made a dot. Anyway, there's a buffer system called the carbonic bicarbonate buffer. What is that buffer? Is the carbonic acid bicarbonate buffer. There, okay, that's what it is. It's not carbonic. Wow. Carbonic acid bicarbonate buffer. This won't show up on your mastery test, but I'm pretty sure this particular buffer shows up on your post test or an end of semester. I'm not 100% sure. I just know I've seen this question and I have this memorized. And I keep telling you guys you have to memorize it. That is really the only thing. In your blood, there's this thing. That's it. The carbonic acid bicarbonate buffer. If you see that, and it's asking about blood and buffer systems, this is the most important buffer system. It's the one that anybody ever talks about. So when we talk about buffer systems, we definitely talk about this particular one. Okay? And this is in blood. So this is the blood's most important. Okay? Most importante. Alright? Super important. So you do have to memorize this name for purposes of your post test and whatnot. I don't really know if it'll do any good to memorize in the future, but hopefully it will. In any case, that is how that works. And then they're going to have one more little thing. I'm just gonna, let's see. I don't have a red pen, unfortunately, but it's fine. They're going to introduce something called litmus paper. Litmus paper are these little slips, and you might have seen them. They're just like rectangular paper slips. And what they would do is, there we go. So this is a paper slip. There's no paper slip. Right. So let's pretend this is my litmus paper, and I have this liquid here. And I would take my litmus paper and I would just dip it in my liquid. And normally this thing would change color. So mine's just a clear piece, I'm sorry, not a clear piece of paper. Mine's just a piece of paper and this is just water. So it doesn't really do anything anyway, even if it was litmus paper. But this would turn, hold on, it would turn, oh, this might ruin my pen. But it would turn blue for a base and it would turn, I don't have a red pen, but it would turn red for an acid. Okay, so blue for base, B is blue base, and red acids. So when you're using these little litmus papers, they turn blue for bases and red for acids. So that's going to show up on your master test a couple of times. They have a couple of questions where it asks, like, some guy dips into some cup or something like that, and you have to figure out how many of them are acids and bases. So blues are bases, reds are acids. So if I dip 3 litmus papers and all 3 turn blue, that means I have 3 bases on my hands. Okay? Okay, so cool. Good excuse for me to drink some water. I don't think there's anything else that'll show up on your master test. I'm pretty sure that's how it'll go out, and I think that's probably the easiest way that we're going to be able to handle this master test. So I'm going to go ahead and cut this video. I know this is just slightly shorter than normal, and I didn't go through the entire tutorial. Feel free. Take a look over it if you want more details. If you have any questions, feel free to email me or call me. But I think this will be enough to get you through your master test. Definitely give that a try first and just see if things work out. Sorry, just in case you still upside down. Just in case you still need the notes, they are there at the end of the page, so feel free to pause and catch up with anything you need to. Alright? Let me know if there's anything I can do to help you, and thanks for watching. I'll see you guys next time.